Hello and welcome to the Projectiles at Angles number 2 video. And as its name implies, this is the second video for Projectiles at Angles. And in this video we're going to build on the first video. There's going to be one change though. The projectiles are not going to be launched on a level surface, or the ground's not going to be level. And so there's going to be a vertical displacement. And I wanted to go through at least one example to give you, to let you see how the math has changed in these types of problems. So let's get started. It says, while standing on a 200-meter tall cliff, you throw a rock toward the water below. The rock leaves your hand 1.7 meters above the ground at an angle of 20 degrees with the horizontal and an initial velocity of 14 meters per second. We're going to try to find two things with this problem. A, how long will the rock be in the air? And B, how far from the cliff will the rock land? And so as always, I think it's a good idea to draw a picture of what's taking place with this problem. And so if we draw our cliff here, here's our 200-meter high cliff, and there's water below. So this was 200 meters. Here is you standing on the cliff. And you throw a rock, here's the rock, at an angle, it said here, of 20 degrees. So we draw in that vector. And it forms an angle of 20 degrees with the horizontal. And what that means is if you drew a horizontal vector right here, it would be pointing straight along the x-axis. And then you make your vertical angle or side of the triangle here, and you have a right triangle. And so this is 20, if I can fit that in still. Angle of 20 degrees. And your initial velocity was 14. So I'm going to put 14 meters per second there. And so kind of the same process starting the problem. Except for there's the biggest change on this problem is that now we have a vertical displacement. And we also have, besides the 200-meter tall cliff, it said your release point, the rock left your hand 1.7 meters above the ground. So that would be this distance from where the rock left your hand and the ground. So I'm going to put 1.7 meters right here. So really the vertical displacement of this rock will be 201.7 meters. And so now we're not doing it on level ground, we have a vertical displacement. And that does change things a little bit, but we're still going to start it off the same way we always do. I'm going to split the initial velocity vector into two components, v sub x for horizontal and v sub y, v sub y for the vertical initial velocity. And so I use trig to figure that out. So v sub x will be equal to 14 times the cosine of 20. And so v sub x is equal to 13.2. 13.2 meters per second. And v sub y will be equal to 14 times the sine of 20. And I'm getting that's 4.79. So v sub y is equal to 4.79 meters per second. Okay. And so now we're going to split it up into horizontal and vertical components. Horizontal here. And we know that equation number 1 can be used horizontally, which says that displacement is equal to velocity times time. Our velocity is the horizontal velocity, so I'm going to plug that in. Displacement is equal to 13.2 meters per second, and that's going to be times the time, which we don't know yet, and we're going to have to figure that one out vertically. And so if we come over here and put vertical, I'm going to list everything that we know vertically. We know its initial velocity vertically was 4.79, so 4.79 meters per second. We don't know the final velocity, so I'm going to leave that one as a question mark. Time initial is always equal to 0 seconds, where we start time, and time final is really what we want to find here. That's really what we're hoping to find next. Displacement initial is the point at which you release that rock is 0. So I'm going to call that 0 meters, and that will be right here where you release the rock. The displacement final is going to be, it's going to hit the water eventually, and so that's 200 meters from the cliff, but we also got to add in this 1.7 meters that that takes into account how tall you were when on top of the cliff. And so really it's going down, so I'm going to call that a negative 201.7 meters. And then we also know acceleration. Acceleration is equal to a negative 9.8 meters per second squared. Okay, now we've got everything that we have everything listed that we know, and we're going to try and solve for time. Again, we need to pick an equation, and we're going to pick equation number 4 to solve for time vertically, which let me rewrite that. Equation number 4 says that displacement is equal to initial velocity times time plus 1/2 at squared. Okay, and if we plug in everything that we know the displacement final was a negative 201.7 meters, and that's going to be equal to the velocity initial, which was 4.79, and that's times time, which we don't know, plus 1/2. A is a negative 9.8, and times that by t squared, and we don't know time. Time squared. Okay, so if I simplify this equation as much as I can here, it's going to simplify to this. So we just keep a negative 201.7, and that's going to be equal to 4.79t, and we've got a minus here, so minus half of 9.8 is 4.9, so minus 4.9 t squared. And so we have this equation, we have two unknowns, or we have one unknown, a t squared, and also this t value. And so if it looks like a quadratic equation here, and so I'm going to move, what I like to do is move this value, the t squared value, over to be positive. So I'm going to add 4.9 t squared to each side, and it will cancel out on the right, and it will be positive on the left. And I'm also going to subtract 4.79t from each side. We'll cancel out on this side, and it'll be a negative on the other side. So let me do that quickly. So if we do that, what will result is you'll have 4.9 t squared minus 4.79t, and this will stay on this side, so it remains a negative, and minus 201.7. Okay, and all of this is equal to 0. And so we have a quadratic equation here. There's really no way of factoring this to figure out what t will be. The only way to find t when you have a t squared and t with a vertical displacement here is the quadratic formula. And if you remember the quadratic formula, it says that t will equal a negative b plus or minus the square root of b squared minus 4ac, all over 2a. Okay, and that's what t will equal. In your math class, you're probably used to saying x equals, but t is our unknown here. We're solving for time. And for reasons of space here, I've gone ahead and I've solved that, and I found that t will equal, t is going to be equal to two values, but one of them in this case will be negative, and time can't be negative, so you're going to throw that value out. And I've found that time will end up, if you do this correctly, time will equal 6.92 seconds. So if you want to try that, plug everything into your quadratic formula, and you should get that time is equal to 6.92 seconds. And if you're familiar with the quadratic formula, this first term is called A. This is your A term. The second term, the negative 4.79, is your B, and the negative 201.7 is your C. So all you have to do is plug it into this formula, and it will eventually simplify down to where t will be equal to 6.92 seconds. Okay, and that's the answer to question in part A, where it says, how long will the rock be in the air? It will be in the air for 6.92 seconds. And then we've still got to answer B, which says, how far from the cliff will the rock land? And this is a horizontal displacement, so we know that the rock's going to come and it's going to start falling because of gravity and land somewhere over here in the water. And so we really want to find out what that horizontal displacement is. So we can solve for horizontal displacement using equation number 1. So we'll plug the time value into equation number 1. We already knew the horizontal velocity was 13.2. We saw for that earlier. And now we just got to plug this time in right here. And so take my calculator, let's see. So 13.2 and times that by the time, which was 6.92. And I'm finding that that horizontal displacement is equal to 91, so 91.3 meters. And so that's how far away from the edge of the cliff the rock will land, 91.3 meters. So hopefully that helps. And remember, the only thing you've got to do when you have a vertical displacement, you will end up using your quadratic formula here to solve for time. And so that's really the only difference between this problem and the ones we've done in the past. So hopefully that helps. On your video physics assignment here, I've got a couple of problems for you to do, as usual. If you need help, go back through the video. If you still don't understand it, come talk to me anytime and we'll solve it. But good luck. I'll scroll through them slowly so that you have enough time to write it down and get everything you need. So yeah, good luck.